What's up, Algebra Squad? This is the second part of the substitutions video. Just a little reminder of what it is that we're doing here. Now, when we have a system of equations meaning more than one line, we are trying to find out where that solution is. Now, what is a solution? The solution is where the two lines cross or intersect. Sometimes we do have a single solution, okay? Sometimes the lines are parallel and have no solution. And sometimes the lines actually overlap. That means they have infinite solutions. So we can either graph or we can do the substitution method. Those are the only two that we've learned so far. And then the next lesson, we're going to be doing the elimination method. But right now, we're going to keep going with substitution. Now, in the last video, we learned how to find the point of intersection, that x comma y. In this video, we're going to be doing two more examples, which is we're going to see how it looks like when there's no solution because the lines are parallel, and what it looks like when there's infinite solution because the lines actually overlap. And remember, parallel lines meaning no solution, that means that the system is considered to be inconsistent, while when the lines overlap, we call that system to be consistent but dependent. All right, so let's go ahead and go. This is actually example number 3. Here we go. All right, so if we were to take the same steps to answer this question as we have done in the previous one, what we would do is we would look for an isolated variable. An isolated variable is a variable, a letter that is by itself. So you could see here in the bottom equation, it says y equals negative 2x minus 4. So we can grab this. We can grab what y equals to, right? Y equals to this, and we can substitute it into the other equations y. Okay, so what would it look like if I write it out with that new addition to it? This is what it would look like. Go ahead and notice that instead of y, I'm writing parentheses so I can insert or substitute this quantity inside of it. All right, from here, we need to do PEMDAS, parentheses first. You cannot subtract what's inside of the parentheses because they're not like terms. The 4 does not have an x. They're not like terms. You cannot add or subtract them. The next thing in PEMDAS would be exponents, but we don't have any, and then multiplication. Okay, so multiplication is a distributive property here, where we would multiply 2 times negative 2. That will give us negative 4x. Then we follow with 2 times negative 4. That is going to give us negative 8. We continue with equals negative 8. All right, what can we see here? Continuing to put things together. Well, we notice that these two things right here are like terms. They're actually the same type of number, so we can add them or subtract them, combine them. A 4 minus 4, or a 4x minus 4x goes away. It's 0. And now what are we left with? We're left with this idea right here. Negative 8 equals negative 8. That right there is a true statement. I know that there's a lot of students that might want to take this negative 8 to the other side, but you don't have to. You don't have to do this extra step. But if you want to, then okay, whatever. They're going to cancel on the left side. They're going to cancel on the right side as well, leaving you with 0 equals 0. Once again, giving you another true statement. So we just generated a true statement. That means we did not get a coordinate. We didn't get an x comma y. So that means there is no point of intersection. What does this mean? Well, a true statement actually, it stands for, whatchamacallit? Overlapping lines. All right. Jesus. My spelling there was atrocious. I didn't even know what I put there. Overlapping. All right, so the lines are overlapping. What that means is that they have infinite amount of solutions. Infinite solutions. And we call that consistent dependent. Okay, there we have it. So all these things is what that means, right? Overlapping lines, which means we have infinite amount of solutions, which means that we call that system a consistent independent system of equations. All right, that is what it looks like. Now, let's go ahead and bring up decimals just so we can see what that what the actual graph of that is going to show us, which is this one right here. Let me just make sure the 4x plus 2y equals negative 8. Okay. Okay. Here it is. So focus on the blue line, focus on the red line. You can see that they are the same exact lines. That means that every single one of these points right here that represents a solution to the blue line will also represent a solution to the red one. And remember, this goes on forever. That's why we say that it's infinite. I can zoom out as much as I want, and all these points are solutions for one and the other. Now, this is what we're going to be looking at now. No surprise, right? All right, so what does that look like? What does a no solution look like? I hope you already guessed it. Now, let's go back to our train of thought of how it is that we solve equations, systems of equations with substitution. We want to find, the first task is we want to find a variable that is isolated. And if there isn't any, make it isolated. So right now I see that this y right here is the best option to make isolated, to keep by itself. The reason is because it has no coefficient, or it has a coefficient of a 1, which is great. By a 1, I mean that one right there. So I'll take x to the other side by adding, and that is all I need, because now y is isolated. Or if you want to call it 1y, great, call it 1y. Whatever gets you there. All right, now that we have a variable isolated, it says y is equal to 3 plus x. Grab that. Grab what y equals, which is 3 plus x, and put it into or substitute it into the other equations y. That is going to now give us negative 3x plus 3. And instead of writing x, I am now writing my quantity. Quantity just means this piece right here, or the sum of 3 and x equals 4, right? Followed by the distributive property right here. We got negative x plus 3 times 3 is 9. 3 times x is 3x, positive 3x equals 4. We notice here that we can combine like terms. These two terms have an x. 3 minus 3 gets 0. We get 0 right there. And then we still have 9 equals 4. Now we stop, and we have to understand that this is not a true statement. This is false. I hope that you made that assumption before we started. So a true statement will mean that the lines are overlapping. Therefore, we have infinite amount of solutions. A false line will mean that the lines are parallel. So parallel lines, which means no solution, no solution. Because remember, solutions are where the lines meet, or you can call them the points that will make the equation true. Since there aren't any points where the two lines meet, then that means that there's no one point that will make both equations true. All right, so parallel lines, no solutions. And then the last thing that we can call this is inconsistent. Consistent. Yeah, my OCD wants to change that. Inconsistent system of equations. All right. All right. Now let's go back to decimals and see what that looks like. And here it is. We have two lines that are parallel to each other, and you can have an idea of why this is if you were to put both of these in slope-intercept form. If you really want to understand why this is the way it is, you can try to put both of these lines in slope-intercept form, which means the following. We already did it with one line. By isolating y, which is the thing that I'm leaving right now on the board, by isolating y, we were able to create, actually, sorry, not yet. This is slope-intercept form, x plus 3. Okay, that's slope-intercept form. If you put the other one in slope-intercept form, you're going to understand that it's going to generate the same slope, but a different y-intercept. What that means, the same slope is the amount of tilt that a line has. So if you have a line that tilts this much, right? Tilt means slope or rate of change, how much the line is tilting, right? If you have a line that tilts that much, and then you have another line that tilts the amount, the same exact amount, but it has a different height, maybe higher, maybe lower, then that means that those lines are parallel. That's what it means. So that would be like the explanation on that. All right, guys. So these problems are found on that page. I am going to go ahead and encourage you guys to get these done. I will show you the answers for these 15 problems in the next 5 seconds. So I encourage you to pause this video right now. Don't look at the answers and work towards those answers. And if you get them wrong, I need you to backtrack. All right. 3, 2, 1. All right. Here comes the answer. Bada boom. Well, here come the answers. All right, good to go. If you got any questions, reach out. If not, peace out.